So, I actually started in 2002 in Hyderabad with a single employee. Now, we have Hyderabad office and also branch office at Visakhapatnam. Now, we have total staff of 55. So, we are doing a lot of RCC structures as well as the steel structures. We in fact pioneer in steel structural design for high-rise buildings in Hyderabad. First, Phoenix have approached us with their requirement for the steel structure, since they lost a lot of time in excavation of a rock in one of the project. They wanted to convert project into a steel structural project. From there, we started our journey, and we have done 20-storied buildings to Phoenix. So, we have done quite a good number of projects for them. After that, we got an opportunity to do data center that is in Navi Mumbai, Mahape. That's a 12-storied building, 72 meters height, for a load of 1800 kg per square meter, live load. So, that kind of a load to support with the steel structure. So, that too they wanted a clean surface. We have done a flat slab with a capital, that what we have done, abutting the sheet from the bottom. Abutting the sheet from the bottom, it was a very Herculean task. So, Kirby has done that work. So, they have made a remarkable job. In 4.5 months, from the bolt to the top level, they have finished in 4.5 months steel structural erection, while they were doing walls and interior work. They have started from below. 12th floor they reached, and the 5th floor they have finished the brickwork all around. So, that kind of a structure also we got the opportunity to do that. And recently we have finished Secretariat of Telangana. Just opposite to Secretariat, we have done one structure that looks like an ellipse. That ellipse structure is a Telangana Martyrs Memorial. That's a huge structure enveloped with a stainless steel. So, that is also a very complicated structure. In the earlier conference, I have presented that also. So, now I am going to explain you the ISH Amphitheatre. ISH is International School of Hyderabad. International School of Hyderabad is, we started in 2005. Why that International School of Hyderabad? That actually it is located in a ICRISAT. ICRISAT campus, it's a 73,000 hectares of land allocated by Government of India. There more than 100 scientists work there. They require a school which is going to the city and coming back. For them it has become difficult. So, people were reluctant to come. So, they invite scientists from all over the world to do research, and they are also into, like they are helping in doing research in a groundnut, millets, all those crops. So, this organization is working, it is a UN organization, it is working even South African countries, like a very poor countries, to develop their crops, yield and all. So, Nairobi, Kenya, Ethiopia, all those countries also, they helped in growing their agricultural yield. So, for those kind of people, they wanted a research scientist. For that, those scientists, they require a premises which can have in their own premises ICRISAT campus, a international school. That international school we got the opportunity to do in 2005. They have finished in maybe in another 1 year they have finished. After that, second phase, somehow they forgot us, they didn't call us. Now they wanted an expansion now. So, how the expansion work they wanted to start with us. So, I will just give a small background to that. So So there is a building. One Sneha ji, आप आइए. Just hold this. Huh? So I'm giving a plan actually. So this is the structure on one side. This is a structure on the other side, and there is a corridor all around, and there is a big courtyard. So they approached one tensile fabric person to give the structural design. So they gave very symmetric nature of a structure. They wanted us to give a certification of that. When I went there to see, but these columns are very light and these are all terminated, and only the way is, this is a main columns which is a holding 3-storied building. This side also there is a main column holding 3-storied building. So what I thought, we cannot load onto this, rather we can load onto this. What I have done, entire structure I have given like this with a triangular truss, so that those members just come and rest on this. Not much of the load will be transferred onto these corridor columns. So I have loaded onto this. This basically tensile structure means it's a wind is the governing case. So this uplift can be taken care by these columns because it is already loaded with a 3-storied building. My job has become a simple, and we designed that design. They liked it. After that, they wanted an amphitheatre in the similar fashion. They liked that idea of a triangle truss with a fishbone structure. That is the reason they wanted us to give a amphitheatre, and they appointed an architect giving the idea of this. So they liked that idea also. FHD is the architect. So then what happened? So they started making this 3Ds, everything, and they wanted a 500 capacity with a unique structure. So that unique structure, how we have developed, this is the structure. So we have given them the idea. So this is the kind of a structure we gave that idea. So in that case, what we have given, only that roof is coming up to this, and it was a shallow, but this amphitheatre requirement was different. So this is around 9 meters was the height. This is 15 meters is the width, and there are multiple things are there. These are the drawings what we have produced. All the fish bones, if you look at it from the top, these are all the fish bones. If you look at from this side, this is the scenario. Okay. Now I'll go to the presentation quickly. This is end product actually. I just wanted to show you because I have already shown you what exactly it is. So these are the architectural plans produced by FHD. So there is a 15 meters by 9 meters is the span other direction. So this area is a preparation and a toilets, and this is a pre-function area which is not connected with this. There is a corridor actually. So this pre-function area also later on they wanted a similar kind of a structure we have designed for that. So this is the stage area, and from there stage it is going up like this, and there is a well here. In this well, people, orchestra, musicians can do their music over here without disturbing the area at the stage. So, this is entire thing is covered with a tensile fabric structure, and also there is a ramp and a walkways also. So, a very interesting structure. So, all around the greenery and all they have developed now. So, very interesting structure they have made. So, I have already shown you, and the structural member what we got is 165 is the main member, and this is the topmost point. They wanted a 4 meters width and a 2 meters height. Architect they wanted, this is a exactly, you know, they have just given the only this requirement, and we have worked out the exactly mathematical equation to give a exact shape, and this shape also we have worked out, so that it gives a symmetrical look. And up to this point we have given only 48.3, and the rest of the things we have given a 60.3 OD members. So, during while fabricating the truss, the fabricator also clueless how it has to be done. They have made a mess actually. So, I went personally there. I took all the measurements along with my engineer. So, we have asked them to do all the measurements, shape, everything. We have looked at it. So, we found that we have marked where exactly it has to be welded, and the shape also we made sure that it is in the exact shape, otherwise no. So, that looks very ugly also. So, and during erection also my engineer used to go there and help them, you know, erection part. So, otherwise no, they might make a mistake, and the beauty is even if only one location we are holding it, but still the structure is intact. The only reason is because it is a triangular trusses, both the direction, like, you know, in a bending in the this direction, bending in the other direction, both are taken care because of the triangular nature of the truss. So, this is again during execution. So, this is they call it as a tensile rainbow. So, all the trusses are being erected. This is another way, and there is a waiting hall canopy also they were doing. This is again one more view. So, almost it is done. So, yeah, here I just wanted to explain. So, this is a pre-function area. Architect gave 4 numbers of columns, but I wanted only 2 numbers because it is open to the students. They may hit to the columns and all. So, that is the reason I wanted only 2, but I just wanted to make it as a lighter also, even when people are looking at it. So, what I have done, I have given knee bracing here to cut down the span. At the same time, for the span movement I have given a structure like this. Just it is a for a budding engineers, this is a lesson, like, you know, where how to reduce the span also. At the same time there is a movement on the span, how to control this span with only lattice with a downward space, I mean single lattice structure we can do this. So, this is the, so they made a function also. In this function all superstar Mahesh son is also studying there, daughter is also studying, and all cine people they are taking all the, 15 lakhs is the per annum fees. So, a normal person cannot afford it. So, but so all the elite people, children, they are studying here. It is a very good college, a very good school, up to 12th class, they have extended now. So it was up to 10th only initially. Now they have increased the capacity. We are doing at the next phase also, we are adding up some of the classrooms for them. My team always helps me with developing the model. So you can see how exactly the model with the sizing, everything, it replicates. One can see the craftsmanship of my team also. Thank you very much.